So we looked at how to find the volume of a object, specifically using a slice, right? So we did it for a sphere, which is a generally well-studied, um, pretty easy to visualize object. But what if we do it with a kind of a weirder object? And again, we're limited to using 2D functions. So we only want to look at objects that we can make using purely 2D functions. So a popular way to do this is to do something like, okay, let's say that we have some function, say f of x equals x squared minus 4x plus 5. And we want to take the region. So we want to take the region bounded by f of x equals 1 and x equals 4, and rotate it around the x-axis. Or I guess you usually say about the x-axis. Maybe makes it more clear. So we want to take this region that will be bounded. So this is a parabola that sits a little bit above the x-axis. So we want to take this region and cut it off at x equals 1 and x equals 4. And then we want to rotate it about the x-axis. And you want to make an object that way. Okay. So these can be a little tricky to visualize. So let's go back to the GeoGebra. I don't know if I'm saying it correctly, but so I have it already pulled up here. So this is the two-dimensional graph of x squared minus 4x plus 5, the orange line right here, and I cut it off between 1 and 4, and I have the green lines here. You can see three-dimensionally what this kind of looks like as well, right? So what we want to do is we want to take this region right here, this part that's bounded by x equals 1, x equals 4, and the x-axis, and we want to rotate it around about the x-axis. Okay, so this is what's called a solid of revolution. Okay, I'll write that down on the notes, but this is what that's going to end up looking like. Okay, so I'll turn these off here so we can just look at what the solid looks like. So it's a pretty weird shape, but that's the power of this kind of idea, is that we can look at shapes that are weirder than just like your typical sphere or a typical pyramid or cube or whatever. Okay, so now we can find the volume of this object. Okay, so we would imagine that it's a solid, right? The way that this is graphed is not as a solid. There's this hole in the middle, but we're imagining that this whole thing is filled in right here. So let's go ahead and look at how we would do this algebraically then. So we want to do the same idea of what we did with the sphere, where we want to take a cross section of this and integrate it, right? And because we found it this solid of revolution here, we found it by revolving it, right? So all of the cross sections are circles, right? So if you just imagine just taking a slice down the middle of this, you're going to have a circle anywhere. And specifically the radius of that circle, so half of it coming off of the x-axis here, half of it would be just the value of the function itself, right? F of x, whatever f of x happens to be at that point. So every cross section of the circle has radius f of x. So we can use this to our advantage to again find the volume of it. So here we're going to integrate from 1 to 4 because those are our boundaries. And then we're going to take all of the cross sections, which are going to have area pi times the radius squared, which is f of x. And then we're going to integrate with respect to x, right? Our bounds should match the variable that we're integrating with. So, f was the x squared minus 4x plus 5, right? So we have x squared minus 4x plus 5 squared. And we're integrating that from 1 to 4. Okay, so we just got to do a little bit of algebra here. Expand that out, and then we can integrate it. We'll take the pi out, make it a little easier. So I already have this written down, so we don't have to do the whole thing, but it's x to the 4th minus 8x cubed plus 26x squared minus 40x plus 25. Okay, and then we'll integrate that, and we'll get x to the 5th over 5 minus 2x to the 4th plus 26x cubed over 3 minus 20x squared plus 25x. And we are going from x equals 1 to x equals 4. So altogether, this should end up being 78/5 times pi. Okay. We often like to leave things in terms of pi rather than getting an approximate answer. But if you want to throw that in a calculator and get an approximate answer, that's fine too. Okay. But anyway, so this is the volume of the object that is created by revolving this area around the x-axis. So again, this is called a solid of revolution. Okay. And the general formula, which we haven't actually said what it is, but I'll just go ahead and write down that the general formula of the volume would be the integral from a to b of the area in terms of x dx. Okay, so we've just been finding a slice and then integrating it, but that's what we're doing, is we're finding the area as a function of x, and then we're integrating that function over whatever region we want to find the volume of. Okay. So same thing we were doing with the sphere, right? We found a cross section in terms of y. We were actually, I kept drawing like horizontal cross sections. We were actually finding like vertical cross sections because we were making the variable in terms of y. But it doesn't really matter. The sphere is symmetric. So, it works the same way either way. But you want to take, it's usually easier to do the cross sections in terms of x because usually it's easier to find the functions in terms of x, right? So let's just do one more example here. And let's just look at, we don't necessarily want to have to draw this every time. How would we do this without kind of drawing it? So what if we take the function 1 over x on the interval 1 to 2, and we find the solid of revolution about the x-axis. Okay, I say that about the x-axis because sometimes they want to do it about the y-axis, or maybe even a different axis, maybe like the line y equals x or something. And the idea is still the same, where you find a cross section. Okay. It just, if you're doing it around the y-axis, it might be helpful to do it in terms of y instead of x, like when we found the areas in terms of y. But regardless, the idea is the same. So here we want to find the area in terms of x. Okay. So the area here, it's all going to kind of follow the same general formula where you're going to have pi times f of x squared. Okay. And then here f of x is 1 over x. You can always take the pi out. So this is going to be 1 over x squared because we're squaring it, dx. And then that's going to be pi times negative 1 over x from x equals 1 to x equals 2. So it's going to be pi times negative 1/2 minus a negative 1. Okay, which will be, that's positive 1, so this will be 1/2. So this will just be pi over 2. Okay, and that is the volume of that that little area that we just came up with here. And I'll just show how to do that on here in case, you know, if you want to explore with this tool here. Let me just work on deleting this first. Okay, so I have a blank page here, what it looks like when you go to this site. Go to the 3D calculator here. You can go to the algebra. It has this plane on by default, which I had turned off. I believe in the settings, yeah, you can turn off the show plane part, which is on the right side of the screen. So we just put in the function f of x equals 1 over x, and then you can specify the bounds. So here x is between 1 and 2. Okay. And then it'll, oops, I put some kind of dot there. I think you can just put a comma or something. No. Oh, I don't have the equal sign. There we go. Okay, now I got it to work here. So we just have this little slice of 1 over x right here, bounded by 1 and 2, and then we want to create a surface of revolution through that. So on here, you can go to the tools and then scroll down to the surface of revolution tool. And then all you really have to do is click on it, and then it'll do the rest for you. You can go back up to move so you can look around at it, and you can see exactly what that object looks like there. So again, the radius, meaning start at the x-axis and then go out from there, because you just want half of half of the diameter of that slice, right? The radius would go up to 1 over x. And then you find the area of that cross section, which would be pi times 1 over x squared. And then you integrate that over the entire region, which is from 1 to 2 in this case.